Okay, all right. Good evening, everyone, and welcome to Smart Learning online training platform. To some of you, this might be the first time of joining us. To many, this is not the first time, so it means that, they're either our existing student or they've attended our webinars or free training in the past. So I want to say thank you so much for registering for this free training, and also for joining today, the day one of the 3 days free ISO 27017 foundation training. Some of you, know me, but for the benefit of those that we haven't met or that have not had the opportunity to maybe to talk to over the phone or even meet face to face, my name is Wale Omolere. And by God's grace, I am the founder of Smart Learning. I'll tell you a little bit about Smart Learning again, just before we get into the training itself. So Smart Learning is an IT security, or what some people will call cyber security. So we are IT security or cyber security training organization. So we do business to business training. We also do business to customer training as well. So for you that you're joining us today, so we would assume this is a business to customer training, but we also, quite big, with business to business training as well. So we train all sort or different types of IT security or cyber security related courses, and this include cloud security courses, also quite a number of non-technical courses that we train as well. So whether you're technical here or whether you are non-technical, there is a place for you on our platform. As the misconception out there that cybersecurity is difficult, cloud security is just only meant for technical people, it is all wrong. Okay, there is a place for everybody within this domain. So again, if you have come from a background where you have not even done anything computer related before, there is a place for you within the space. So what we do in a simple terms, or simply, is we help people to up their skills and also support them up onto the point they feel comfortable to apply for a job, and thereby they get a job. All right. It can be very, very simple. So as a business, we provide end-to-end training for our students, so it does not just end when we train you. We go as far as, providing all the mentoring that is required, on the job support to the point that you feel comfortable in that role. All right. And this is what we do. And that is what we do, and we do very, very well. I mean, if you want to learn a little bit more about us in terms of what we do, you can visit our website, www.smartlearninguk.com, all in one word. And, you'll be able to learn more about us and the courses that we offer. And if you're unsure, about, our testimonials or some of the things that we have done or we have helped people to achieve, please, by all means, you can also visit under our testimonial as well, where you will find, testimonials of people like you that seemingly do not have any knowledge in cybersecurity, cloud security at all, and they've been able to make the most of their time on our platform. So today, and in the next 2 days, all right, up until Saturday, you would be hearing my voice. So I would be your host, and the conveyor of this training as well, which is Roy. I don't know if he's here yet. You would hear our voice more frequently. All right. But what we're going to be doing today is to train you on cloud computing. The fundamentals or the foundation of cloud computing is what we're going to be showing you today. But more importantly, we also want to teach you how ISO 27001, ISO 27017, relates to cloud computing. So it's like a double barrel course, okay? So on one hand, you will learn the foundation of cloud computing. On the other hand, you would also understand, the principles of 27017 and how you can apply that standard, all right, to cloud computing. So you would agree with me that you're getting two just for one, so again, I'm really excited and I'm glad that you're here today, to come and learn, something new. All right. So since the day that we put this out to this free training that we wanted to help and support people, I've worked very hard in the background, and I have carefully, all right, created this course curriculum that we're going to be sharing with you in the next few days. And it would interest you to know that this curriculum meets, BSI standard. Even it surpassed the BSI standard for cloud computing foundation. And the reason being that I am a practitioner, and the gentleman that is going to be taking us through this journey is also a practitioner as well. So we have carefully done a lot of research to look at, from academic viewpoint, what you should be learning, theoretical viewpoint, and also what you should be learning from practical viewpoint. So we have combined both words together, and and I'm so proud, I'm so excited as well that we have a very, very robust curriculum today that we're gonna be, sharing with you. And like I said, it meets the standard of BSI, even it surpasses that standard as well. And today being the first day, this is what we're going to be covering, with you. We're going to look at the introduction to cloud computing. All right, we're going to go as far as, teaching you cloud computing architecture. All right, it's important that I quickly say this. So the architectural part of it, we would try as much as possible to teach you the what and the why, but not the how. Hence this course is a foundation course. Okay, so we will not go in depth. It's important that so that I set the expectations. All right. If you want to learn anything beyond what we're going to be showing you in the next few days, then it will just mean that you have to reach out to us, and we can tell you how you need to go about that. All right. Then next, we're also going to be showing you what we call the ISO 31000, the risk management framework. All right, that is commonly used in the cloud environment. There are so many frameworks that are out there, but there are few that are commonly used. All right, Steve, you cannot record this section. All right, this section is being recorded. All right, and we would share the recording with you. We will put it on our platform. All right, we would also put it on our YouTube channel as well. All right, we will put it on our YouTube. So the section is being recorded, but you cannot record it. I hope that answers your question. All right, I would also, so this is what we're gonna do the first day, which is the day one. Then ultimately the second day is where we will now go into the 27017. All right, so today we will lay the foundation, teach you about the fundamentals of cloud computing. Then tomorrow is when we would now narrow in on the 27017. He said the challenge is if you try to learn the 27017 without having a thorough background, in cloud computing, you might find it very difficult. All you just know is the standard, all right, but you will not understand how it applies. So it's very important for you today, to listen and also to listen very, very carefully, all right, so that once you grab the concept of what the foundation is, then the standard would be very, very easy for you to apply anywhere you go. All right. So we're going to start off with the curriculum. And that curriculum is we're going to start with the key terminologies. And like I said, some of you here, cloud computing might not necessarily be new to you. All right. Maybe, you've done it before or you've heard it before, you've done a short course, but for the benefit of those that haven't done it before, all right, that is maybe this is new to them, we want to build it from ground up, all right? We want to, teach you a little bit about, the terminologies that are out there, all right? We will look at various definitions and abbreviations. That's very important. In cloud computing, we use a lot of abbreviations, and you must know what those things, mean, all right? Then we'll go into the introduction to cloud computing. We're going to teach you what cloud computing is and why cloud computing would explain a whole lot around characteristics. It's very, very important. Cloud computing is different from traditional computing, but what are the characteristics? What are the things that is common to cloud that makes it different from the traditional IT computing that we do? Then we'll move on to start to tell you about the deployment model. You also have to understand that as well. So we have different models that is out there. We have the public, we have the private, we also have the hybrid and the community cloud as well. All of this is what we're going to show you. And more importantly as well, we're going to teach you, the service model as well. So maybe the service model, some of you might also be familiar with this. So we have the infrastructure as service, we have the platform as service, we also have the software as service as well. Then obviously we'll get into the architectural part of it. I said something earlier on, the architectural part of it is not to go into in-depth, all right? This foundation course will not cover the in-depth of architectural part of cloud computing. As a matter of fact, we'll touch on the component, both the front end and the back end, what makes cloud. Then, we'll touch slightly on the OpenStack and also the cloud stack as well. But more importantly, what you need to learn, under the architectural model is what we call the cloud computing roles and responsibility. So for some of you, that may want to, that you might get really excited and, you want to go all out and maybe want to write your CCSP, which is the Certified Cloud Computing Professional exam, or you want to go in the direction of maybe, vendor specific, cloud computing certifications like, the AWS, the, Google Cloud Professional, just naming. So if you want to go in that direction, then it's important for you to understand this concept of cloud computing role and also responsibility as well. So I mentioned something earlier on about the risk management standard. It's also important that I quickly say it here that this course is not about teaching you risk management, okay? But you see, you cannot talk about cloud computing without touching on risk management. So for some of you that may end up, in a project where you have to select, different cloud vendors, then it's important for you to understand the standard that is out there that you can use, when it comes to selecting vendors. All right, we're going to look at all of that as well. But what I like about the risk assessment is I've carefully built in a case study into this course that you will like. So even makes it more practical and hands-on for you as well. So it's not going to be theoretical, all right? So just watch this space. It's all going to be really, really exciting and something that I promise you that you're going to, learn from it, all right? Then obviously from tomorrow, that's where we start to talk about the 27,017. We're going to look at the difference between 27,017 and 27,002. All of the new controls, all right, that has been built into 27,017. We're going to look at various annexes. I've already put it there: the access control, the policies, roles, and responsibility, the access management, supplier relationship, event log, operating procedures, and we'll move all the way. But you know what is even more interesting that I also would like to show you in this aspect of the training is the cloud data jurisdiction and regulation. You don't want to miss this. So what I've done carefully with this curriculum was, I've built in a little bit some kind of framework, all right, an illustration that would help you to see the relationship between various regulations and jurisdictions. And when I say jurisdiction, I'm talking about location. Some of you know a little bit about cloud, and you may have heard about cloud instances, all right? So instances just talks about where the data that you store in your cloud reside, all right? So Azure can have a cloud instance in somewhere in Ireland, you may have an instance somewhere in Germany, and when you think about regulation and location, okay, so there's a big contrast there. All right, so for example, now in UK, we're heavily regulated and we have the GDPR. But if you have a data if you have a UK data stored in America, all right, so how do you reconcile that? What sort of regulation, you have to consider in that area? So what we've done in this course as well, to look at that, various regulations that are out there, look at various instances, location where data are stored, and what you need to, what you need to take into consideration. All right. So very, very exciting course, I must say. And lastly, there we're going to show you the ISO 27017, how it apply to ISMS, and also the market acceptance for 27,017. You would agree with me that this sounds quite exciting already. So fasten your seatbelt, be ready because we are ready now. So in the next minute, I am going to, so sorry about that. So today, I assume Roy is available. Is he ready?
Yeah. All good to go.
All good to go. All right. Yeah. So thank you. So in the next few minutes, I would introduce my trainer for today. The conveyor of this training is in the person of Roy. Roy is a dear friend and also a business partner as well. We've been in this business of helping people to better their life the last couple of years. I happened to meet Roy while I was working for Accenture, and since we have kept or maintained that relationship, which has been great. The last time we had a free training on the 27,001 Foundation, some of you that was here, it was Roy that took that training, and I bet that the reason why you're back here is because you enjoyed it the first time. So, and I'm glad that you're here again. Roy would be conveying this training today and tomorrow. And I would be back tomorrow as well. And on Saturday precisely, where I'm going to be teaching you or showing you the career progression, which would be the icing on the cake. All right. So Roy is ready, and I believe you're ready as well. So Roy, welcome. And I am going to unmute Roy, and I am also going to flip control to you, Roy, to make you a co-host. The recording has already started, so jump in and so take us through this journey. Thank you.
Okay. I hope everyone can hear me.
Yes, we can, and I have made you a co-host, so you can share your screen if you want.
Just like we did the last time, can we just go with you sharing the screen when I need it? Yeah.
Okay.
But anyhow you want it, I think
you would just only ask me to be moving my screen. It would be better if you can do it at yours. But if
okay, that's fine.
Move, that's fine. All right. Okay. Happy to do that for you, to be your navigator, if that works.
Sorry about the trouble.
Okay. No worries. Okay. So yeah, over to you.
Okay. Welcome everyone, and Thank goodness for cloud computing that we can meet even in these days of coronavirus. If not for cloud computing, you and I will not be having this meeting. So we have cloud computing to thank for that. We, especially for those of us who would want to take it beyond just this foundational training, would be very useful to get used to key terminology. So if we're going to do the exam as an example, and even beyond that, if we are going to be in a group where we are networking with other people that are either specialists, analysts, or in a workspace or the career space for information security and cloud computing, you want to be sure about the terms that you use and that you throw about. So some of the key terminologies we should take note of is who a cloud consumer is, and on the other side of the fence, a cloud service provider, the provider of services to the consumer, and the kind of services that we consume as well. The three basic ones are the software as a service, platform as a service, and infrastructure as a service. So we'll look at that too, not just knowing that it exists, but what they look like and what the context is of all those service models, as they call them. We'll also be familiar with wide area network, which is how the services could be deployed in a wide area network. It's also possible to do it in a local area network. And especially true because we'll look at the evolution of cloud computing, where we've come from and how it used to be deployed in a small area or a local area until now, where it's vastly ubiquitous in places. And of course, virtualization is a key theme in cloud computing, what a resource is that will be used and what will be consumed, elasticity in terms of what you can add onto the service and what you can take out of the service, and of course, OpenStack and CloudStack on how to manage your cloud services. Okay. Yep. Now, if we look at how we've always done our IT services or computing, if we are to stay true to the terms, traditional computing would have involved us buying lots of computers if we're a large corporation, or a number of computers if we are a small business, or even within our domestic environment. If we wanted to combine services or get more out of our computers, would have a stack of computers, would need spaces for them, create space in our premises. They need to be, they need the environment provision in terms of electricity, cooling, temperature, humidity, static, and all those things. And then, of course, those who would manage them. Now, if we were looking at the traditional on-premise IT deployment, you see that there are so many layers. The data itself will be housed in an application which will run on a software, and that's in a database, because a data should reside in databases. And then, of course, the operating system that may have come natively with the hard computers, we could also maybe virtualize them so that we optimize the use of space, of memory, of storage. The next layer would be physical layer. Then you could have a network layer, which could be wireless or wired. You see that there's so many resources. And then we could have storage in the network, or the storage. We could also have a network attached storage, whichever way we want to do that. And all that, whether it's in a dedicated location as a data center or within our premises, we would also think security. So we would also consider, apart from administration of all these layers, would also consider security of all these layers. If we are wise and we have the budget, we would have individuals run different layers on this stack, or maybe one person doing more than one. And if we're not so lucky that we don't have so much resources in terms of budget, we might say, hey, Tunde, take care of all this. And then Tunde's family will not see him. So that's how traditional computing has always been. You might have one person do all these things on this stack, or you have different people do it. So it's resource intensive. Now, if we look at it vis-a-vis cloud computing, you see whether we are building or buying, but we're looking at it from the perspective of buying rather than building. So that's why we look at it from an acquisition model. If we are acquiring, then we are buying assets, and then we might build the technical architecture as we just saw. But cloud computing, rather than buying assets and moving about and maybe getting injured, something dropping on your fingers, you just buy service. You sit down in your home, sit down in your office, and just buy the service. The architecture is already included. In the business model layer, you pay for assets, and there's administrative overhead as well, as we just saw. That is for the traditional computing, while for cloud computing, you pay for use in the business model. Okay, and there as well, there's reduced administration function. So you see in each one, there is a benefit in the cloud computing side. In the access model, where you just want to access, we have internal networks, and then of course you have corporate desktops, which might even include thin clients or more heavy stuff. While for cloud computing, it's over the internet and you can connect any device. And for the technical model, it is single tenant, of course, for traditional tenant, but of course we started seeing things like desk sharing and hot desking, where we can rotate the devices that we use. So, but typically we were looking at it from the traditional sense. This computing was static. If you are provisioned a hardware, you stay with that hardware. So it's non-shared. But with the advent of cloud computing now, we have multi-tenants, meaning there are more than one user or users that could make use of the cloud computing that is given. So it's scalable as well. You can add, you can reduce, it's elastic, and also dynamic, meaning you could be in the UK and get access to your service and then fly in the air within a few hours, get to another geographical location anywhere in the world, any other continent. As long as there's internet service, you can have access to the cloud services as well. So that is how dynamic cloud computing is. While in the delivery model, it's costly, it's lengthy, negotiation is here and there, you might get what you want, there might be different deployments, but in the cloud computing side, there's reduced deployment time because you are just asking for a service. It might already be taken. You might say, oh, add such and such for me, or take that and that out for me. So there is fast return on investment with cloud computing. Thank you. So in terms of other computing models, as a matter of fact, the evaluation to where we are now with cloud computing, these are the other kinds of computing we should be aware of. There's grid computing, which we'll look at in detail in a bit. Grid computing basically meaning we are combining resources from different domains, different administrative domains, but looking to achieve a common objective or a common task. That is grid computing. And you'll see a picture of it when we look at it in depth. With utility computing, it's not too far from what cloud computing is, but in this sense, we are looking at utility services, okay? The packaging of resources, which is metered like a public utility, electricity, water, and such. That is utility computing. That's what makes it different from cloud computing, which is more commercial. Utility is more about basic amenities, if you like, while cloud computing can be the other stuff where services is sold. Okay, so grid computing plus cloud computing gives us grid computing plus utility computing gives us cloud computing, because grid computing is achieving a task, but it started off in a small area network. Now we are doing it over the internet, and we have now included utility, which is services. So traditional utility was for all the things that we found was useful for us in terms of amenities. Okay. And that's why you see the evolution to where we are today, where everything can be given. It started with grid computing. Now, grid computing is basically an architectural style where computer resources are combined from different domains to solve large problems. Okay, it shows here that it was made mainstream by Globus Alliance, where we want to achieve a common objective, but we combine computers on a network to achieve together. Now, this makes it a little different from what a supercomputer could be, because a supercomputer would carry out a task all by itself with no pieces given to other small computers. But with grid computing, there is a grid, there is a network of computers, and you want each of the computers in the grid to carry out various tasks to achieve a common objective. And this can be done on a specialized application or specialized software and things like that. You, if you, for those of us who might be aware, from time to time they do things like competitions between humans and computers in chess games. Now they use a supercomputer with really high processing speed and all those kind of things. But with a grid computer, you want to split the processing to different units and different nodes. So that's grid computing. An example of it is given with the search for extraterrestrial intelligence, where the organization uses telescopes and other tools to scan space for radio frequency sounds over a wide range. Now, the scans from those the results from those scans will be converted into files for analysis by different nodes and different individuals to achieve what they are trying to look for. Aliens, if you like, from outer space. Okay, so that's grid computing. With utility computing, like I told you, it refers to utility services like electricity, telephone services, water, and gas, okay, typically provided by a utility company. Now, whether it's electricity, telephone, and all those kind of things, you are either given the service and then you pay for it backwards, or you pay for it and you're giving it after payment. Whatever it is, you are billed on the basis of what you need and what is useful. Okay. Sometimes it can even go to IT services as well, but traditionally it was a metered service for amenities that we required. And then in 2005, so that was between the 90s and 2000. And then by 2005, we started seeing network-based subscription applications. And it typically gained great momentum from 2001, but became more seen in the world in 2005. And then by 2007, we saw next generation internet computing and of course data centers with all the needs that and the heavy investments by companies like IBM, Amazon, and the rest of them. So they now started deploying cloud computing and giving it as a service. Okay, so our introduction to cloud computing now. Yeah, so now let's see cloud computing before we go into the security of it. Now, cloud computing provides us a way to access applications like we just saw, utilities and other kinds of things, software, infrastructure, and the rest. And it allows us to even create, configure, and customize applications if that's what we are consuming. We can also have access to database resources or whatever it is. As we see it today, these are all done over the internet. Okay. So the speed of the internet, the strength of the internet, and the usefulness of the internet makes cloud computing what it is today. Yeah, so the cloud we refer to, of course, is not the one that is heavy with rain. It basically is service one way or the other at the end of a network or even the internet. Okay, and every cloud service eventually refers to a physical location. So no matter what it is you're consuming, at the end of it, even in a long chain, there is a physical location. It is somebody's rack, somebody's stack, somebody's data, somebody's application, database, storage, network that contains everything that you consume. There is a physical location eventually. Okay? Your provided services over a network, it can give you emails, you can have web conferencing like we're having here now. It could be a customer relationship management tool, everything running on the cloud. You want to manipulate, configure, and access these things online. It offers online data storage, infrastructure, and application. Okay. Now, there is no one single definition of cloud computing, but once you have an idea of what it is, and if you go to some of the best practice standards like NIST, the National Institute for Standards and Technology, as an example, giving this definition, or Encyclopedia Britannica or SANS, some of these places you go to give definitions of cloud computing. As an example, NIST has defined it as a model for enabling convenient on-demand network access. Key thing there, it's convenient, it's on demand when you need it. Okay, you get network access, and typically it's a shared pool of configurable computing resources. So it's a shared pool. There are other tenants. That's what we said before. And of course, we're talking computing resources. These computing resources could be networks, could be servers, could be storage, applications, and other kinds of services. So that is a very good definition. On demand, it's convenient, it's elastic, it can be rapidly provisioned. You're not taking anything out of the box with wraps around them and things like that. You're not hurting yourself. You're not waiting on someone. You're just paying for it and getting the service or demanding it. And anytime you need it, no matter where you are, you get it. Minimal management. Depending on the service you are consuming, there's the management level, whether you would do more of the management or whether the service provider will do that management there. So the model will tell us what it is we're doing and who has what responsibility, which we'll see in a bit as well. Now, our cloud model, as been defined here, promotes availability because we said it is rapidly provisioned and it is on-demand network access. So the availability in the key principle of security in confidentiality, integrity, and availability is already given as a key characteristic of cloud computing. And then we'll see the other services and deployment models and see what else they give. So when we say on-demand self-service, depending on your level of interaction and your level of need, you can interact with the cloud service that is provided. Okay, you can provision computing capabilities without speaking to an administrator on the other side of the service provider. You can ask for more server time interacting with the service directly. You can get more storage, increase your storage space. Of course, all this, as we said, is metered. So the more you ask for, the more you pay for. So whatever your budget is, you can get what service you need. Okay, and as we go along, you'll see the typical characteristics of cloud services. Started with the fact that it is on demand and it can be self-service with little interaction with a human. Okay. It's also broad and ubiquitous, meaning it is pervasive. It covers a lot of ground. It's everywhere now. It's available over the network, can be accessed through standard mechanisms and tools, can be accessed from anywhere. Anywhere there's internet connection. Of course, we said an internet connection is always required. And if you have that and it's stable, you have the service that you need. Okay. It also promotes heterogeneous thin or thick client platforms, whichever one suits the business. we also mentioned about multi-tenancy and resource pooling. Multi-tenancy, as the name implies, means there are many people that can be contained within a service provider's pool. You can have so many neighbors in multi-tenancy. And resource pooling meaning we can share. That's all about cloud computing. That's one of the key characteristics as well. Apart from being on demand, is resource pooling. You don't have to spend to have your own tools and then manage it by yourself. They are managing it and they're just giving you what you need. So that means it is meeting your needs rather than just your wants. There are some places we've gone and done some work for in terms of asset discovery and asset security. And we find that they don't even know all the assets they have. With cloud computing, you are getting what you need because you are paid for it and it's housed by someone. And the resources you're getting is just what you need. Okay, so the provider's computing resources are pooled to serve consumers. Storage, processing memory, you're only using memory that you need. Your bandwidth, if you're taking too much, you're paying for a whole lot more. So you see, it has these good characteristics. Meanwhile, it is location independent. There's no control over the exact location of the resources. But with having said that, with the General Data Protection Regulation now, there's the need to be sure of the eventual location where if personal data is being used somewhere, you know what security measures and mechanisms they have in protecting personal data. But from a characteristic perspective, you can access cloud computing anywhere you are. So the consideration for security will come later on. We also mentioned about rapid elasticity. As soon as you want to add more resources, you can get. As soon as you want to scale down, you can. So it's elastic in that regard. Okay, so it can be rapidly and elastically provisioned. It's also in terms of how much you can get, it all depends on the service provider really, but it is considered to be unlimited as long as you can pay for it. So there's unlimited virtual resources. And of course, sometimes they give you a condition to say, because we have other tenants, we would, from a service provider perspective, ask you to sign a fair use policy. So you would have to sign a fair use policy to use cloud services. Okay. We saw this from the beginning when we looked at the evolution of cloud services, that the metering capability in terms of a measured service allows the cloud service provider to offer a service and you only pay for what you use. It can be switched off, you can pause it nowadays, you can ask that it be suspended, come back on, whatever it is you want to. So it is a measured service. So if, as an example, even if you have created one virtual machine on, say, Amazon Web Services, you will be charged only for the time that the machine is running. And that is one of the, okay, I've seen a question what a fair use policy is about. Okay, so even if you have one virtual machine on Amazon Web Services, you will be charged only for the time when the machine is running and not when it is switched off. And they even tell you that upfront from the beginning. So if you use 4 hours in a day, you'll be charged only for 4 hours and not 24. Now, in terms of what a fair use policy is, they might tell you it's unlimited, but they want you to consider other tenants as well, to say, as you are using your resources, and maybe you've said you've gone through some question and answers. How many hours do you think you use in a day, in a month, in a number of time, and then eventually a year? And say you've said how much you want to consume for a period of a contract as an estimate, but the trend shows that on a daily basis, you are taking the maximum, 24 hours, 24 hours. Meanwhile, working time is, say, 8 hours in a day or 9 hours maximum, but you are going beyond 9 hours in terms of how much you are using it. If that's not what you have asked for, then you are not abiding by the fair use policy. you are in a way taking away from those who might want those resources as well. So a fair use policy says consider other tenants as well. Okay, the fact that we've told you unlimited doesn't mean you should kill our network, right? Now, some relevant cloud technologies and also matching it with the characteristics is access. Okay, so it can be heterogeneous, whether with thick clients, that means thick hardware, servers, and things like that, or thin clients. Okay, you can have it on PCs, mobile devices. There are some here tonight who may be connected from their mobile devices. Remember, we said this meeting we're having is all thanks to cloud computing. So it's possible to connect from your PCs, your mobile devices, some handheld devices, wherever and whatever it is, it's possible to have broadband access or internet. It can be wired or wireless, of course. And then, of course, the service can be hosted in a data center. These data centers have large computing capacity. They can be distributed. And in terms of storage, could be distributed access storage devices or storage area networks. So it's either the devices allow for direct access or they are connected in a network of devices. Some other cloud technology is virtualization. So the concept of multi-tenants is what we see in virtualization. Virtualization is what gives the idea or the impression that there's more space, more memory, more resources, more operating capacity than there actually is. We can have a number of operating systems on a single device with virtualization, okay? And that is where the concept of multi-tenancy comes in. You can have several guests on a single host, a single machine, and have several other operating systems. Nowadays, we can even have desktops, we can emulate hardware, we can emulate memory, and things like that. So that is virtualization, okay? You are decoupling from physical computing resources, and some of the types we have are hardware types. There's the Zen one, that is the VMware style virtualization. Okay. Yeah, so apart from operating system virtualization or desktop virtualization, it's also possible to have memory virtualization. You can have application virtualization, processing virtualization, storage virtualization, and data virtualization, and how each one works. For memory virtualization, you are decoupling volatile random access memory from individual systems and giving the impression that there's more memory than there really is. With storage virtualization, you're abstracting logical storage from physical storage, okay, to give the impression of more storage area, just like memory. And then, of course, for data virtualization, data is an abstract layer, and it is independent of the database systems, the structures, and the storage. So it's giving the impression of data being there when it's done. Okay. Yes, we go on with network virtualization as well. So all the layers we saw in our traditional stack, we can actually virtualize them, and that's what we've just seen. So virtualized network addressing space can even give us better security, and that's what we have in VPNs, virtual private networks, where we have created a tunnel for security on a place where typically it's not secure, like the internet that is open to everyone connecting. We create a tunnel with the security mechanisms and security technology, like internet protocol security for some VPNs typically. So that's another way of doing network virtualization. like we just discussed and said, virtualization is very, very key to cloud computing. Yeah, it is what enables what we do in cloud computing by creating an intelligent abstraction layer. So this abstraction layer is transparent to the consumers. We don't see that. We just ask for services and we get it. The multi-tenancy we also talked about, like I said, that is the idea between behind cloud computing. Okay, so virtualization is key to cloud computing. What service providers actually do is virtualization on a large scale. So where they host in you could do it remotely or locally on your system, where you virtualize on your desktop, on your servers. You have multiple operating systems in one machine, as an example. That's what eventually cloud providers do. They provide a number of operating systems or a number of things on their servers and give out the service. So virtualization is the bedrock and the foundation of what we do in cloud service. Okay, and all that comes with security. So if you understand virtualization, whether on a small scale, what you're eventually doing in cloud computing is looking at it in a broader perspective and looking at giving it out to more people, covering a larger area than you would if you were just looking at it from typical primary virtualization. Okay, so we just expressed that to understand cloud computing, we should have basics of virtualization, understand virtualization from even how we deploy it locally. Some of the basic things in virtualization is an understanding of the hypervisor. The hypervisor is the mediator where resources make requests and the hypervisor prevents them from speaking directly with the host potentially. So the hypervisor it takes all the requests and provides all the resources as a middleman. Okay, we can also virtualize the operating system and also virtualization as the hosts as well. So virtualization can be configured in all these different ways. Now let's look at some examples of cloud computing with the idea that eventually it's what we do in terms of virtualization, having the right virtualization technology, which we've looked at, and then of course, the different ways we can do the virtualization, whether it's operating systems, whether it's virtualizing storage or the host operating system, desktops, or whatever we want to do it. Eventually, that's what we're doing. Now, these are some of the examples. Without knowing it, when you make use of Yahoo, you make use of Hotmail, when you log in and you are given video service via YouTube, when you store your files in Google Drive or Dropbox or Amazon Drive nowadays as well. These are cloud services. Your Twitter, your Facebook, all these are services. But of course, some of them are free. Some of them, of course, have premium and you pay for. So these are cloud services that you actually consume. And then for businesses themselves, they might have their human resource systems and capabilities hosted and delivered via the internet as a service. Of course, your enterprise resource planning solutions as well, like Salesforce, and then the supply chain applications might also be delivered as a cloud service. So these are just examples of them. Now, when you have an idea of what cloud service you want, the next thing is, how would this be deployed to us? So we're going to look at the deployment models, and then of course, the service models. So these are services and models and deployment models. We have to be able to differentiate between the two. It's very easy to confuse, of course, but very easy to understand as well. Okay, so deployment models and service models. The deployment models is how they would be deployed to you. Would you have them shared with other people and other businesses and other entities, or it as in a public deployment model, or would it be private to just your business? That is private cloud deployment. It could also be a hybrid, a combination of more than one of these deployment models, and then a community cloud. All the people attending this class today might be given a link to a location, and only those who have attended this course would have that access. That is an idea of a community cloud. People who have or entities with a shared interest out of a public cloud or a private cloud, just a specific class of membership would have access to community cloud. Okay, so private cloud is where the service provider makes resources available to the public via the internet. Okay, whatever resources it is, whether it's storage, application, anything any of the services we've talked about can be deployed as a public cloud. Okay, and then it is private when it is proprietary. That means it's to a single business entity. It's either for smart learning, smart learning services. They've asked for services and they've been given access to that service, and it's only for smart learning as a business entity. As with other types of environments, private cloud provides extended and virtualized computing resources via physical components over the internet as well. Okay. Now it is a community cloud where it's accessible by a group of organizations that have a shared interest. Okay, they have a shared interest, and they are getting this service from the same service provider. Okay, so they might put their resources together, maybe to reduce cost or for some other kinds of interest. And then it is hybrid when we combine one or more, more than one of these different ones we've talked about. Now, a multi-cloud environment is where an entity uses more than one cloud platform that delivers a specific application or service. So you could have Amazon Web Service. You can also now have Azure, and then you have your own private cloud. That is multi-cloud. Okay, so whether it's no matter what kind of deployment model you have, it becomes a multi-cloud. Multi-cloud different from hybrid means you have different kind of cloud service. Okay, you can have Amazon, you can have Azure, and then your own private cloud. Okay, so that is different from what we referred to as hybrid. Okay, so multi-cloud will be comprised of public, private, and edge clouds to achieve your end goals. Okay, you combine on-premise operations, and then you get other things from the cloud as well. That is what is referred to as multi-cloud environment, and that is the example of it. Okay, edge computing, on the other hand, which we've just seen, edge cloud, is a way of bringing computing as close to the source of the data as possible, so as close to the consumer as possible. That is edge computing. Okay, what you want to do is you want to try to reduce latency and bandwidth use, bring it home. That is edge computing. So when you hear people talk about edge computing, that is what they are saying. You want to reduce what you have in the cloud and bring a few of those things within your premises. Okay. Okay, Tony wants an example of edge computing. Yeah, so where we have already described it as those things that you want to take off the cloud and bring closer home. So it's a concept. It can be any, okay. I just saw two questions. Tunde, please, can you read them out to me, because I don't want to click on the screen. The last two questions. And Chris said something about Netflix. So those are the three things I just saw across the screen.
I can read them out if that's okay.
Yes,
okay, well,
please.
you take that. Yeah.
All right, cool. Thanks, Tune. So
Thank you.
Kingsley says, would PPV TV program fall in that category? So I suppose this question is relating to the edge
Computing.
cloud computing that you mentioned. I mean, just before you answer that question, Roy. So I don't know how many of us are familiar with IoT on this platform. I mean, quite a number of people they know IoT on the back, of this
Internet of Things.
yeah, on the back of coronavirus. I think so. There's all of this crazy speculation going around that the reason why we have coronavirus is as a result of Internet of Things. So the concept of Internet of Things, yeah, it kind of worked well with edge computing, and I like the way Roy described it when he was talking about services that you cannot afford to have long latency. Again, if you come from networking background, you would understand what latency is. Latency, in other words, just talks about delay, all right, where you can't afford to have delay, for example. And that can also be true if you've ever worked in a networking environment where, VoIP, I don't know if some of you are familiar with, VoIP, where, if you're talking to someone, the speed of the network must just be as equal as the way you talk, all right? And the packet will not be able to aggregate at your other hand in a way that, it would make sense to whoever is receiving that information. All right, so the concept of latency and delay, is what make edge computing or edge cloud computing different. All right, so for service provider, all right, there are often certain type of services that latency or delay on the network is so much critical, then edge computing would be something that they would go for. I hope that answers your question, Kingsley and others. But in terms of PPTV, I'm not sure what that is. Roy, do you know what PPTV is?
That's pay-per-view.
Pay-per-view TV.
Oh, okay. Yo, sorry, the acronyms. Apologies. All right. Yeah, it might be true actually, because pay-per-view, I suppose that there will be voice, there might be video as well on it. And again, you would agree with me that if there's a whole lot of delay on the network, your video, the packets, don't forget all of these things are packet. All right. They might not be able to, all assemble in a way that, it would form a right picture for you. It might be, but I know that for edge computing, it's mostly used in IoT environment. So those are the technology of the future.
Fantastic.
Well, they're here anyway.
Yeah, well done. And recently I had an issue that a client lost some emails, or emails were sent to the wrong people. And in this day and a few of them had personal details that they didn't want to go out, and they were now running helter-skelter. Now you see, just like Wale described latency, the delay in services getting to you or traffic, that is latency. So you could decide, hey, instead of putting everything out to the cloud with our service provider, let's keep some within us. That you're bringing it to the edge. So when you can deploy it back into your environment, whether on your IoT device or a server, that server will now be called an edge server. That means we have taken it away from the cloud and brought it back within our environment. It could be emails, it could be storage. I have a small box here that gives me the same thing I could get in Google OneDrive and all those. So I have it in my home. All I need is an internet connection, and I will store it locally. So that is now an edge server. When you bring those things that you can deploy in the cloud back into your environment, it becomes edge computing. Okay.
Roy, there's one question here by Ngozi. She said, "Oh, can you please help with the difference between hybrid and multi-cloud?"
Cloud. Okay. With multi-cloud, if you just go back one slide, please. With multi-cloud, the combination has to be between public, private, and edge clouds. Okay, public, private, and edge. And then if you look within, not just that, you are using different services. You have Amazon, you have Azure, and then you have your edge. Okay, so that is multi-cloud, different cloud of clouds. And then with hybrid doesn't have to have up to 3, just more than one makes it hybrid. So a mixture of public and private makes hybrid. Okay, but with the multi-cloud, it is more than that. Okay, you're using more than one cloud platform. You have public, you have private, and then you have edge.
And it's also important for you to know, because you asked that question, that the reason why enterprise organization, they would choose whether hybrid or multi-cloud, it depends on the sort of services that they're offering per time. Okay, sometimes what actually also drive whether it's an hybrid or multi-cloud could also be risk. All right, so risk might also be driving it as well. As you know, with cloud, with private, you have more control. All right, with the public, you do not have all of the control that you need. Okay, so it's so many things would drive the type of model that businesses will go for per time. Risk, most importantly.
Okay, somebody asked the question, what if you have 3 private clouds? You still have a private cloud. You have 3 private clouds. It's not multi-cloud, it's not hybrid.
Oh, so is that question for me? Oh,
No, I answered it. I saw the question and
okay,
then I just answered it.
Okay, then.
You have 3 private clouds, you still have 3 private clouds. It's not multi-cloud, it's not hybrid.
Okay, all right. Sorry, I thought it was for me.
I saw the question quickly, that's why.
All right, okay. So we should go on then.
Yes, please.
Okay.
Thank you.
Is this where you are or?
Yes, yes.
Okay.
So there are a number of reasons why companies might want a multi-cloud infrastructure, and these are the benefits: to prevent data loss or downtime, to avoid vendor lock-in, okay, to avoid vendor lock-in, to achieve broader business and technical goals. As an example, provide competitive cloud services. Private cloud is not the same as edge computing. Edge computing, you're bringing it down back to your traditional computing. With private cloud, it's still a cloud service, but it's within your network. Okay, it's not physical, you're still virtualizing it. But with edge, there's no virtualization. So with private cloud, there is still virtualization, but with edge computing, it's physical and separate. Okay. Yes. Ben? Yes, please. Edge computing, you're bringing it back down to traditional computing. You're taking it away from the cloud. The reason why it's edge is you're bringing it closer home. Private cloud, it can be with a service provider still, but with edge, you are in control. With private cloud, you might still be getting service and it's just for you, it's dedicated. What makes private cloud private is that it is dedicated to an entity. It can be you providing it to yourself, or it could be a service provider, but with edge, it is within your control. Yes, on-prem. So a multi-cloud has all these benefits to help you meet your regulatory requirements, as an example, to achieve optimal performance, and of course, to reduce latency that we just talked about, drop in bandwidth consumption or traffic. So we've looked at the deployment models. Now we're looking at the service models. And one way to easily differentiate between the deployment models and service models is that with the service models, you have the S as a service, okay? So the deployment models are the public, private, hybrid, and community, while the service models are the infrastructure as a service, platform as a service, software as a service, what service you consume. is the service model. These are the basic models. Nowadays, there are many more service models. These are them at the basic. So software as a service allows you to use software applications at your end. Example, Salesforce, NetSuite, or Stini. Okay, it is based on how you use it. It's usually multi-tenant because it's software. Okay, it also has highly scalable architecture. Okay, so these are the typical characteristics of it. Some even go as far as getting accounting software as a service, Sage, and the rest of them. Collaboration, where you can work. What are the example collaboration software that you know? Tello, yeah, and some of them. Project management software, management information systems, enterprise resource planning, rather than invoicing, accounting, and all those things. The service you just get online. So rather than installing it on your system, you just subscribe to it online. You are given an account and you can log in anytime and do your invoicing, as an example, do your HR, like smart recruiters. So you don't have them on site, you have them online. That is software as a service. For platform as a service, it allows you, it gives you runtime, it provides the runtime environment for your applications. Okay, that means you can configure with your platform as a service, because that's runtime environment for your applications, for your development and deployment tools as well. Okay, it gives you all the facilities that's required to support the life cycle of building and delivering your web applications. That is how to differentiate between software as a service and platform. While software as a service stops at what service you need, particularly for doing a service, with platform, it gives you more administrative and management effort to do. So it can allow you build your applications throughout the life cycle. It goes beyond just the software itself. Okay. Examples are given there as well. Now, for infrastructure as a service, it's the delivery of the technology infrastructure that goes beyond the platform. Now, when we talk platform, we're talking operating system, and like we just saw, the runtime environment. With infrastructure, you have much more than that. Okay, you are provided the physical machines, the virtual machines, and virtual storage. It goes beyond the application. It goes beyond the platform. It's now the infrastructure that you are given. Okay, examples of them: Terramac, Blizzard, Entity Communications, and OpSource. Okay? It can be coupled with managed services, that is the operating system and application support, or it can be given separate. Okay, basically you are renting computation and storage space as a metered service, and you'll see them from the perspective of all the things that are in the stack in a bit. Okay, so you see in this slide, you can identify what you are already doing in the cloud, either as an individual or as a business entity. We started with the traditional on-premises computing, from data to the data center, everything. When you are doing co-location, you are only using a data center. You put your stuff in the data center. Okay, so you are renting space in a data center. That is what co-location is. For many years, that was the business model. And then they started doing much more than that. You now, hey, let us get a host. What does the host do? The host has the physical servers, has the network storage and the data center, and then everything else we're doing ourselves. They are hosting for us. Okay, so your virtualization, operating system, databases, and the rest. And then now, here, with infrastructure as a service, even virtualization, that means they have more than one tenant. And that's where cloud service now comes in, from the IaaS, the PaaS, and the SaaS. And when it's the IaaS, it stops at the operating system. You manage from the operating system to the data, just there. Everything else is managed by the service provider. With platform as a service, it goes past the operating system.
Ooh, that's good. I'm gonna destroy Leicester, man.
It goes past the operating system and the databases. Okay, so the only things managed in a platform as a service is the application and data. Very easy to get that. And then, of course, in software as a service, only the data is managed by the consumer. Everything else throughout the stack is managed by the vendor. So, number one, if I were you, if I'm taking
You understand? So how we didn't know who has the money? It's also like trying to find out who are fraud.
Hello, please mute yourself if you're talking money. Citrix, that's a very good question. I personally consider a Citrix as PaaS. Tunde, Wale, correct me if I'm wrong.
Sorry, what was your question, Roy?
Somebody asked if Citrix is SaaS or PaaS.
So Citrix is an application, all right. So you can't say Citrix is a PaaS or it depends on how it's being used, all right. So it's a type of application. In fact, it's a lightweight application, and usually when you have an infrastructure, all right, what most organizations would do is they would have Citrix, installed. It's usually an application between the infrastructure and the client. So it does not fit into any of the service model. All right. So it's
very good answer.
Yeah.
It actually is. People like to look at it as a software as a service, but more correctly, it is desktop as a service. Yeah. But it's not one of the primary ones we are looking at here. So yes, it is software as a service, but more correctly, it is desktop as a service. Okay. Okay. Next.
Okay.
Now, cloud computing architecture is the next topic we'll be looking at, because the services offered by cloud depends on the architecture behind it. These are also dependent on the hypervisor. Remember, the hypervisor is the mediator that takes the request and delivers the service, because we also said you needed to understand virtualization, which is at the foundation of cloud computing. So we'll look at service-oriented architecture, service-oriented. We'll look at tiered architecture, multi-purpose architecture, and then, of course, the data center architecture. Okay. Oh, I just saw, Wale, you gave a caveat. Sorry, guys. So we will not go into the details of the cloud computing architecture in terms of those four architecture. It is beyond the scope of foundation. Please pardon me on that. Okay, but those are the four cloud computing architecture style. Okay. Now, cloud architecture refers to the different components in terms of their databases, the software capabilities, applications, and where they sit, how they interact, how they are, how they deliver the service from start to finish, and the relationships between each one of them. That is architecture of cloud. Yeah, every aspect of the cloud system of the cloud computing and how services are delivered and what role each one plays and how they interact with themselves. That is cloud architecture. So you have the front end platform where the service either takes off or comes in. Can we move to the next slide, please? So you see all the components of cloud architecture: the front end platform, the software, the back end, the cloud-based delivery. This is the architecture. So at the back end, what do we have? We have the application, we have the service, we have storage. But throughout as well, we're considering security. So you see the service, the cloud runtime, the storage, the infrastructure. While in the front end, you have the software, the user interface that matches with the back end as well. And of course, the device, whether it's mobile, whether it's server, whether it's a PC or laptop. That is the front end architecture. And of course, how both parts of the architecture interact with each other. Okay, plus the runtime as well. Yeah. OpenStack and CloudStack. These are cloud orchestration architecture. Essentially what they do is they make cloud computing management more efficient. Okay, basically how you can automate the delivery of services or the management of everything in a cloud service. You can use either OpenStack or CloudStack. It does the orchestration. It provides a way to deliver all the functions that cloud services and cloud computing can be in the way it can be used. Okay. Now, OpenStack and CloudStack have these goals to deliver in cloud services. To provide open source components. They are both aimed at service providers building public clouds and consolidating their resources. They include a compute function allowing virtual machines to individual servers, and they also have object and block storage systems, basically a way for storing either to the bit level or block level storage, depending on what use the business requires in terms of storage as well. So OpenStack and CloudStack is used to manage your cloud services in an automated fashion. Deploy, be flexible, and use all the elasticity that comes with cloud services. Okay. As you can see, OpenStack, as the name implies, is open. We have Kubernetes, you have Cloud Foundry, Terraform. All these things can be used to build and manage your cloud computing platforms. It lets you deploy your virtual machines as well and handle different tasks on the fly, basically making the management of your cloud services seem seamless and transparent to the end users. Okay, so you can configure it and have it run as well. We won't delve deep into this because we are doing the foundation class for this. Now with CloudStack, a little different from what we saw, this provides a flexible orchestration platform to deliver private and public clouds. Okay, it's an open source management platform as well, delivering infrastructure as a service for public and private clouds. Okay, it provides a way for interaction between the cloud clients and any of the service models that we talked about already via an API, an application programmable interface that makes the interactions between the two seem like they are, even if you are using different vendors, will make it seem as if they were built by the same vendor. So allows it to be seamless as well. So CloudStack has a monolithic architecture. The installation processes that are required a medium level of time and expertise, but it has a strong graphical user interface and the Amazon EC2-like command line interface as well that provides foundational security services and mechanisms as well. Also has some load balancing capabilities, meaning it distributes the load that typically one system might bear. With OpenStack, it is fragmented and it's not monolithic. I mean, it is distributed, okay? And it gets driven by multiple command line interfaces as well, different from CloudStack, which has a GUI, which has a GUI. This is a command line interface, meaning you have to type it like, and it's not too user-friendly like CloudStack is, okay? Okay, so shared responsibility or roles and responsibilities is very important. Who does what in cloud computing? Of course, we already saw how uh, in terms of administration, there are different layers where some are managed by the service provider and some by the client end. It's the same with security as well. Some by the provider and some by the customer. And all this must go down in the agreement from when the relationship is established to say what role each one will play, what they can do with resources, what they can do with support, and then, of course, the service level agreements that the service provider has to meet up with the consumer, whether they would be the one requiring what's data protection service and mechanisms and security as well, like business continuity and response when an incident occurs, because they want to meet their regulatory requirement as well. So this shows us the shared responsibility model. This is the AWS example. Okay, there are, of course, other cloud providers have their model, but this is the one we're seeing from the AWS perspective, the Amazon Web Service perspective. So it shows what part becomes AWS's responsibility and the aspect where it is customer responsibility. As an example, the customer is the one that brings the customer data that they want to host. They must have their own encryption and data integrity authentication solved. This is very important. Like I said before, in this day and age of GDPR, you want to have played your part in terms of what you're supposed to. You cannot give all the responsibility to your service provider to handle what you have got from your customers, like your customer data. So you must have provided security up to that level. Then, from the business perspective, from server-side encryption as an example, because they are going to be storing your data, they must provide protection for data at rest, because data will be in their databases. That's based on what service you're getting from them. Network protection as well, because it will be in their environment or it will be delivered to their environment via the network, via the internet. So there must be protection like virtual private network, like a VPN protection, to get that data delivered to their environment. Then platform and application, every other layer of the stack is now provided by the provider, in this case, AWS. Okay. So each party has a role to play. Now, for specifically, as we continue with this, breaking it down now, the cloud service provider's responsibility of security of the cloud, they are responsible for protecting the infrastructure that runs all the services once the once the data is delivered. Okay, so that's point where data is handed off to the service provider, the responsibility for security now becomes theirs. Okay, so we have the hardware, the software, the networking, because they will make requests, they will pull software when the consumer wants access to their data, it will be delivered. When they want to maybe upgrade, make use of the elasticity of cloud, the service provider has to provide it. So you see where the responsibility lies. Okay, data at rest and data in transit. But for data in use, that is where the consumer or the customer responsibility comes in. So they go to the customer, they get customer data. They're using it as their business data. So the platform, the application, identity and access management becomes their responsibility. Who are we giving access to? Even the service provider, have we done all our checks on them with regards to security and their administrators, their workers, their personnel that will be having access to this data? That becomes our responsibility. So identity and access management is customer responsibility. Of course, your operating system, network, and firewall configuration. Don't forget, we said this is the AWS shared responsibility model. Okay, so that's why we're looking at it from that perspective. So in this place, customer responsibility is determined by what relationship would be had between the two. So the types of responsibilities can be inherited controls, that is controls where a customer fully inherits from the cloud service provider. very easy to understand that inherited controls are controls which a customer inherits from cloud service provider, physical and environmental controls, where it is handed off from the customer to the provider and vice versa. Okay, if it's going back the other direction. With shared control, very important that you take note of what controls are shared. Patch management. Before you hand over to the service provider, you must ensure data is up to date and everything else that needs patching is patched to the latest version, operating systems, applications, and things like that, so that you do not hand off inherited vulnerabilities. Just like you have inherited controls, you could also have inherited vulnerabilities. You want to have done everything that you should have done before handing off data. Configuration management, just in line with patch management as well, but this time for more configuration items than just software, okay, like operating systems, databases, devices, and the rest of them. It goes down to hardware too. Okay, and then you have some customer-specific controls, which is what we're looking at here now. Some customer-specific controls. So this picture is a very, very beautiful picture. If you look at the legend in the next slide, you will see that it shows the shared responsibility model. Can we go to the next slide, please? Yeah. So you see, it is a very, very important slide. Very, very important. It shows the responsibility similar to what we saw before. Yeah. But here we are looking at it from the security perspective as well. You are managing everything when it is on-prem, all through the stack. But with infrastructure as a service, you are managing from the application to the operating system. And then the virtualization, the space you need is, of course, by the service provider, the server, because it's now data at rest, the storage and the networking. That is infrastructure as a service. It stops at the operating system. In the other picture we saw before this one, we included databases, but this is from the security perspective. We saw a similar picture some slides ago, but this has now taken away the databases. This is the security perspective, okay? And then in the platform as a service, it goes all the way to runtime. And the only aspects managed by the customer is the application and the data. And this is platform as a service. So you consume, the service provider takes the operating system, the middleware, and the runtime as well. With software as a service, all the way through to the application is managed by the vendor, and you only have access to software via the internet. So they manage everything throughout the stack in software as a service. Tony wants to know when a service provider or vendor is responsible for a data breach. When a data breach occurs, the facts of the matter have to be looked at. So we can't just say they're responsible. If the data breach occurs where the data is in the database, as an example, if it was breached in the database in their environment, then they are responsible. But we can't even just say they're responsible. You must have been written down in the terms of agreement, in the shared agreement. You must have stated that when it occurs here, there, specifically, this is your responsibility, that is my responsibility. So it must all go down to the contract. But without looking at that, if we're arguing for argument's sake, everything that occurs, which is what should go down in the contract, everything that occurs in my environment becomes my responsibility. If it's my database that was hacked, that's my responsibility. I should have put the security controls in place. You can't blame the customer that was sitting down somewhere for that. Although to their own customer, that is the consumer's customer, they do not know who you are hosting. They do not know who you are hosting with. So they will not take those people to court. You can take them to court. They know you. They gave you their data. So it's you that will be responsible as far as they are concerned. And to the regulator as well, you have the relationship with the customer. So you are responsible. Whichever way you want to resolve your problem with the service provider, you will do that. You should have done your background check. You should do your review from time to time to see that they are compliant and that their security measures continue to work. And that is where your responsibility comes in.
Absolutely spot on, that explanation, Roy. So, Tony, see, the overall responsibility of data is with the cloud customer, all right? The overall responsibility. So, for some of you that might want to take this training or this, what you've learned here further. And what do I mean by that? You might want to go ahead and want to write some exam certifications as it relates to cloud, particularly around, particularly CSP, which is the Certified Cloud Security Professional. And, one of the fundamental question that has been asked, usually when you're writing that exam, or if you look at some of the practice questions, is the question that Tony has just asked now and the response that Roy gave. So the overall responsibility is with the cloud customer, not with the provider. So if anything happens at all, it is the cloud customer that would be held responsible. Don't forget, the cloud service provider might also be liable as well, but you must be able to prove that. And if you look at cloud computing, from what Ras just taught us, the place of forensic is very, very important. Obviously, it's beyond what I'm talking about now. Is beyond the scope of this training. So forensic is massive, is big. All right. So there must be, post-mortem kind of analysis, investigation to prove what has happened and who should be held liable. But again, the overall responsibility sits with the cloud customer. I hope that helps. Right, go on.
Okay. So the ISO 31000 standard is a risk management standard, generic management standard for risk management. Okay, we have 27005, which is for information security, but for a generic risk management methodology, you would refer to ISO 31000, meaning you can use these principles and the methodology in any industry. It doesn't matter what industry it is. So it is a standard that was published in 2009 and provides the way for doing effective risk management. If you understand this, as you can see, the cloud risk assessment framework is based on this standard. So having an understanding of that allows you to see what kind of risks there can be from cloud computing and how to put the right controls in place and refer to the control repository to put the right mechanisms in place to prevent these risks from becoming manifest. Okay, so we first would define what risk is. Okay, risk by definition here is the chance of something happening that would have an adverse effect or an adverse impact on the business's objectives. So the business would have objectives. We want to serve our customers. We want to produce our product, laptops, laser pointers. That is your objective, the reason for your being. Risk will be that thing that would stop you from achieving it when you need to achieve it. Okay, so that means it will affect confidentiality, integrity, and availability. We want to have done it by the end of today. What will stop us from doing it by the end of today? What will stop us from not doing it well? What will stop us from not doing it and would disclose to those who don't have a need to know? That is risk. Okay, the effect of uncertainty on your objectives. And this is what it looks like. So visually, you first of all would establish the context. That means in what industry does the business operate? What are its peculiar risks? What is the size of it? What are its products and activities? What are the regulations around the business? That's the context everything that you know about the business that you establish is where you start from. Because when you do risk management, it's not a one size fits all. You have to come from the context, what industry it's in, what laws govern it, what standards they selected, what kind of technology they use, what's the size of the business, what's their management style, their risk culture. When you get an understanding of that, that is the context. Okay? It helps you set a risk appetite, knowing the contractual obligations, the risk that they face, and the regulations that they are governed by. It means you can, yep, you are establishing a reason for being of the business and its inherent risks. Okay, its weaknesses, its strengths, its opportunities. You start from there, and then you do a risk assessment, identify the different risks, either from an asset perspective or from sitting together and brainstorming or many other methods. Identify the risks, analyze the risks, prioritize by evaluating them from the analysis, and then suggesting treatments that would either accept the risk, reduce the risk, share or transfer the risk, or avoid the risk. So the risk treatment would come in those 4 ways. Okay, so that's the methodology in 31,000. And throughout, you would have been communicating and consulting with the right people, reporting to them, getting feedback from them, asking them questions, getting answers from them, basically engaging with the right people. And of course, monitoring and reviewing risk and the different elements within the risk throughout, because any of those elements can change. They might not stay static. Risk is dynamic, besides making sure you are capturing the right elements in terms of whatever changes occur. So in applying the process, this is what happens. The established context means you would understand the external context, the regulations, the suppliers, their contracts that they have. That's the external context. What drives them, what constrains them, laws and regulations. That is external context. And then the internal context is what are their weaknesses, what are their strengths, what technology do they use that is peculiar that would allow you to understand the risks that is inherent in the business, what's their culture, that's internal context. And then of course, the organizational structure, who reports to who, okay? And then again, you now have the risk criteria. Remember, I said eventually what that context helps you establish is the risk appetite. Okay, so that's the context. Secondly, you now move on to identify the risks. What can happen? You must understand the key processes, the tasks and activities. What can happen? What assets do they have? How would it be? How would it be affected? How would it break down? That is identify the risk. When you identify, then you analyze. Meanwhile, the second step, the third step, and the fourth step is what we refer to as risk assessment. When we talk about risk assessment, we're identifying risk, we're analyzing risk, and we're evaluating risk. So when you identify the risk, you then analyze them. That's where the calculation for the risk is, to try to get an understanding of the likelihood of it happening or the impact of it happening. It allows you to determine the level of risk. So for the different risk scenarios, you would have different scores of risks, then prioritize them in the evaluation step. So the evaluation step is where you prioritize them from the different scores you get from step 3. So when you now prioritize them, so say the first risk we analyzed is 1, the second is 2, and on like that, we can then treat them in order of priority, which would be step 5. Okay, so we can share by insurance or by outsourcing it. We can accept to say it's within our appetite. There's no benefit in doing anything, taking any action around it. We'll just monitor it. We're not going to spend to do anything on it. Or we can reduce it by implementing controls, buying 1 or 2 things that would help us manage it. Okay, we can add controls, we can train, we can do audit and compliance, or we can even avoid it to say, hey, it's going to affect us badly. Let's not do the activity that would let this risk appear. So let's avoid the activity, discontinue it. okay? Or we could reduce the impact, yeah, by business continuity, by adjusting the contracts, or even by public relations, okay? Tell lies, yeah? Employ someone like Michael Flynn, okay? And then, of course, we can review and decide eventually, because risk is dynamic. Like we said, you want to review your risk treatment to see if it's effective, if you've managed to do it within your risk appetite and within budget as well, so that you can make a request to management next time to say, we've helped you save costs. Eventually, effective risk management is one that allows you to contain or manage your risk within your budget. Okay. So now we'll just look at the top security threats that are associated with cloud computing. Now, what do you know? A number of people have asked questions tonight, and they were all asking data breaches, data breaches. And as you can see, data breaches is number one. It's at the top. That is the top security concern. That is the top security threat. Could also be insufficient identity, credential, and access management. We are not provisioning correctly. The wrong people are having access to the data. That is a top security threat. Could come from internal, could come from external by way of hackers having access to it. Okay, seeing the data that they shouldn't be seeing. Our interfaces and APIs, application programming interfaces, might be insecure, allowing different programs to talk and allowing different applications to have access where they shouldn't have access as well. System vulnerabilities, the system we use could be vulnerable, accounts could be hijacked, malicious insiders as well, for the same thing we said about identity and access management. APTs, advanced persistent threats, where the threats are very sophisticated, they are persistent, and of course advanced. Could also involve nation states and government arms and very sophisticated organizations. We could lose data. Could be insufficient due diligence. We did not check with whoever it is we're interacting with. Julius, what are you sending? Nobody speaks Martian here. It could be abuse and nefarious use of cloud services. It could be denial of service. And then, of course, shared technologies issues where compatibility becomes a concern. Okay, and here we have the explanation. Yeah, data breach is a top worry for management, of course, because we've mentioned regulation. And not only that, you have trouble from the regulators, you could also have trouble from the customers where you have exposed their data. Equifax had that issue recently. BA, British Airways, had the issue too. And we hear of data breaches over and over. So many Equifax, TJ Maxx, some of the more popular ones. And if we don't do proper checks as well, if we don't do proper identity, credential, and access management checks, then of course, we might be giving access to those who don't have a need to know. We've talked about interfaces and APIs. APIs are, they form the backbone of the cloud environment, of course, because different applications will be speaking, different individuals will be having access. Okay, we're talking about elasticity of on-demand access. Now, who are those that we're giving the access to? Yep, we need to have secure interfaces for individuals and for programs, because machine-to-machine talk as well. System vulnerabilities in the architecture deployment and the discussion we had about the architecture, the different systems in our architecture needs to be secure. We need to understand what vulnerabilities there are, make sure we have a baseline secure provision and configuration where security will not go below a certain level, and we can be sure of the security that we would get from whatever deployment we are taken. So the system vulnerability is important, and we do that from time to time. Accounts can be hijacked, of course. And as you can see, it's not unique just to cloud environment, but it is also a concern to cloud environment. Okay, as you can, it's even more significant than in a traditional data center model where it is physical. Okay, except your network is as weak as we know them to be nowadays. In a cloud model, that is a very major concern because you have given that contract out to a service provider and potentially you've not been allowed to do a physical examination of their infrastructure, and you've had to rely on either a certification or an attestation by the cloud providers themselves. Say, hey, we have all these things together. So account hijacking becomes a concern. It could be malicious insiders similar to that. We don't know who they've employed. We only know our staff and all the checks we do, which the way we push our HR department to do checks on people and background checks. But what about the cloud provider on that? Our own insiders and the cloud service providers' insiders can be a threat to our data or the data we host. We could also lose data different from data breaches. This data loss might be as a result of the technology that we use. A failure in that, we could lose it through encryption keys, accidental deletion, and corruption of data. This is different from data breaches, where it is forced by an actor. With data loss, it is by the technology or the system that we use. Wale, do you want to take the case study?
No, I think you should go ahead and just walk them through.
Okay, very good. Now, this is an important slide. Why do I say it's important? It shows us the different elements in looking at a threat occurring in risk management. What are those elements? There has to be a threat actor. The threat actor is the action or the actor that causes the threat to happen. We also can also show them in two ways, internal and external. For the external, typically there would be malicious hacker. I don't like the fact that they said Eastern European here, but this is a case study. So we are not creating it from nowhere. It happened. It could have been any actor. Okay. For the internal, if you skip basic standards, like we said, the baseline configuration, if you skip it, then your security is not up to scratch to what you have decided by yourselves. So beyond the threat actor, then you have the threat. What threat comes with the internal threat actor? What threat comes with the external? That is how to show risks. That is how to do a threat assessment. So with the internal, you could have denial of service. You could have data pilfering. You can have so many things. The threat is an action. The actor is an entity. So what action, what does the, so I'll come back to the slide. What security management tool can you download to use? There's the Microsoft Threat Assessment Tool. Yeah, it's free to use. It breaks it down in this regard as well. But that one is used for applications more like. I will share something later on. Just send your questions to Wale. Wale and I will interact and we'll give you the tools that you need for practicing as well. So the threat from the internal perspective is denial of service. From the external perspective, shared technology vulnerabilities, meaning because we are sharing technology, there are vulnerabilities, there are weaknesses, and the threat can occur from there. It is weak, and so a threat happens. The vulnerability is the weakness that allows the threat to happen. When we say denial of service, what would cause it to happen? Oh, insufficient identity, credential, and access management allows a denial of service. The same weakness allows shared technology to fail. Okay, so the vulnerability is what allows the threat to happen. If it happens, what's the impact? If I step in the ring with Anthony Joshua, what would happen? I'll receive a punch, I might lose a tooth if I'm lucky, or more. That is impact. How bad will it be? It could be financial, it could be operational, it could be compliance, and it could be reputational. But at first, we look at it from a technical perspective. What's the technical impact? Data breach, loss of user credentials, personally identifiable information can be lost. That's the impact. Okay. Yeah, that is Ruby Kitcher. That is a different example. This is a specific example. So malware can be a threat as well. Malware is a threat. Okay, so if we're doing for malware as an example, it will come under threat. Okay, so you look at it from the actor, the threat, the vulnerability. By decomposing it like this, you get a very good understanding. And you see, eventually, when you now know the impact, you say, because we can have financial impact, what can we do? Look at the controls we should put in place. And controls must be deployed in layers. Prevention is better than cure. But prevention, no information security is foolproof. Information security controls are not foolproof. So after the preventive control, which could fail, we must have a detective layer. Detect it if it fails. If it fails, we detect. And once we detect, we can respond with corrective controls. What are these controls in terms of preventive, detective, and corrective? We put the references and then the details right. As an example, EKM02 is key generation. So if you say insufficient identity, credential, and access management, as a preventive tool, because of the impact we've seen, we can implement EK. What does technical threats want? Is a reference to the document where this is taken from, Joseph. So all these letters and numbering are taken from a specific document, and those letters, you just like we have controls listing them here. So we have the same for technical impacts. There's a page for impact, there's a page for vulnerability, there's a page for threat, and you just pick the right ones and plug them into a specific scenario. So this is one scenario, and the threats are listed. You are taking typical threats for this kind of threat actors. You're taking typical vulnerabilities from that repository. You're taking technical impacts, you're taking business impacts, and even controls. Everything is already there in the document. 31,000 does the same thing. You take each one and you just plug them into different case studies. So this is from 31,000. Okay, so benefits and risks of cloud services. Yes, Mayowa, all these controls are in 31,000 as part of the annexes. We'll look at it tomorrow as well from 27,017. We have a number of controls in that too. Okay, yes, so somebody is asking if it's safe to say storage is at the infrastructure as a service level. It is there in, it starts with infrastructure. Of course, on-prem, you can have your own storage. It's in the infrastructure. It's in platform as a service where you are not storing yourself, and even software as a service. When you are only getting software, then of course storage is there too. So you can have it in each one of them. You can have it in infrastructure, in platform, and in software as a service as well. Okay, so the benefits and risks. Very, very good observation, Mayowa. All these standards speak the same language or are saying the same thing, but speaking different languages. Because it's a foundation course, we did not emphasize on it, but when you get down to it, they are all saying the same thing, okay? So yes, they are similar to the NIST one as well. So the benefits and risks of cloud computing will depend on particular circumstances, such as the service and deployment model, the importance of the service to the business, the source and sensitivity of the data created, where the data is processed and how it is stored, the quality and experience of the service provider, and all of those. Okay, so we can have all of this with the threats and vulnerabilities based on cloud service models. Now we're breaking it down to the different service models to look at those threats we talked about. So as an example, data breaches in terms of the possible vulnerabilities of targeted attack, simple human errors, application, poor security policies. It can happen in all the service models. So the service models that are susceptible to those vulnerabilities is the and for data loss, the possible vulnerabilities that would allow data to be lost include natural disasters, of course. It can take the whole data center. Human errors, hard drive failures, power failures, and malware infection. Somebody asked that question. When that happens, the service model that is susceptible to all these vulnerabilities is infrastructure as a service, not software, okay? Because natural disasters can take the physical location. So infrastructure as a service is susceptible to this. Hard drive, software doesn't have hard drive. So it's infrastructure as a service, okay? So if you are doing the exam, this will be an important page to take a note of. And it continues. For denial of service, for vulnerable systems and APIs, all those threats we looked at earlier, we break them down here in terms of what service models they affect. Can we move to the next slide, please? Yeah. So you see, we have denial of service, vulnerable systems and APIs, weak authentication and identity management, and account hijacking. 27,017 has an exam. So this is foundation. We're just letting you get an appreciation of 27,017. But if you wanted to go higher and get a qualification, you would need to do an exam and get the certificate issued to you by PECB, the Professional Evaluation and Certification Board. So some might want to get a qualification to say, I am a cloud security qualified person and I've done ISO 27017. So you do the exam, you get the certificate. Wale will tell you all of that, about all of that, either tomorrow or the day after. Okay. Yep, so we talked about the characteristics of cloud. The name of the exam is ISO 27017. So the benefits of cloud, next slide, please. We've already looked at some. There is also lower cost and financial risk because it is pay as you go, or pay as you grow, or pay as you use. You are only paying for what you need, remember? So there is lower cost, there's lower financial risk. Yeah, there's also hopefully better cash flow because you'll be saving, only paying for what you need. We've already looked at elasticity and scalability. You can go up, you can go down. You can expand or reduce the service you consume as you want it. Okay. I think we have reached the part where Wale takes over.
All righty.
Continue with 27,017, I believe, tomorrow.
Tomorrow. Roy, thank you,
Thank you
for your time. It's always a pleasure to have you here. And thanks to all of our audience that stayed to the end, which is exactly 8:39. Thanks to everyone that joined on time. Some people have been here since around 6, I believe, about 6:30-ish. And then here we are. So we've come to the end of the day one of the ISO 27001 cloud computing training. So thank you guys. I hope that you have enjoyed your time. You have learned something new. Just a quick announcement. The day 2 continues tomorrow. The good news is we recorded this section. So what that means is we would make the video available on our website. If you are following us on YouTube, or if you are subscribed to our YouTube channel, then you can just go there and just go watch it. Alternatively, we would have it all uploaded onto our website where you can just go and watch all the videos that we have published, the training videos that we have published, including the ISO 27001, and I mean a few other cloud-related videos, training videos that we have. We have for AWS, we have things around IoT and GDPR as well. So, I mean, a lot of free resource that you can avail yourself of. All right. So tomorrow is going to be the day 2. This is where we're going to be narrowing in on the 27017. As you can see, we're going to be covering the scope, the context, and the structure tomorrow. And the plan is we're going to cover all of this tomorrow up until I think there's going to be an aspect where Roy is going to be teaching us about, you know, data in the cloud, location and jurisdiction, and also regulations as well. So you don't want to miss tomorrow, ladies and gentlemen. If you have any issues connecting today, so maybe you have difficulties, I would just suggest that, you know, try and log on as much as early as possible tomorrow. The bridge is going to be open at 6 and the training will kick off at exactly 6:30. Tomorrow, there's not going to be any introduction. So I believe that we're going to start on time, and, you know, chances are we might even finish, you know, maybe around 8 or 8:30. Okay, so I would implore you, come back tomorrow so that we can, you know, have the full dosage of what Roy is going to be showing us. On Saturday is the grand finale. So for some of you that are interested in getting the certificate of participation, you know, like we said, there's going to be a learning assessment, like a mini exam. If you do that, then you will get a certificate of participation from us, and we would be able to reference that for you as at any time that you want them or you need them. Also, there's going to be a section on Saturday as well. We're going to be talking about career progression. So a lot of you have learned what cloud computing is now. And listen, it does not end here. There's a whole lot that is out there that would also like to show you as well. So earlier on, somebody was asking about, you know, exam like the 27017. All of that is what I'm going to be bringing on board, we'll be bringing to you on Saturday. We'll look at various possibilities, the exams that are out there, the certifications that you can do, those ones that we can recommend, the ones that we think that maybe they are too, you know, difficult, or they might be too very high level for you at the moment. You know, everything that you need, you know, to make, you know, your time here worth the while. You know, we're going to be sharing that with you on Saturday. And Saturday is very, very important because you need to progress from here to the next level. What we'll do today is we'll look at some of the questions that was asked in the chat box. So maybe if for any reason we have missed out your question, that will be the first thing that we're going to address tomorrow. The tomorrow before we go into the training is going to be looking at, you know, some of the questions that you have asked. I mean, maybe even provide better answer. It's going to be more interactive tomorrow, as we're going to be rounding up tomorrow than Saturday, coming to do the assessment and you know, and again, you know, the assessment and the career progression thing. All right. So again, I want to say thank you. If you know anybody that was supposed to be here today that they couldn't join, or they feel that they've missed out, tell them that, you know, the actual training is going to start tomorrow and they can still join us anyway. All right. So to Roy and to all of my colleagues that have worked really hard to, you know, to make this possible, say thank you. And then we'll all return tomorrow. Don't forget the bridge open at 6 p.m. Okay. Today, I hope you've been able to take some of the note, there. What I will do is, so whilst we still have some people here, we might just be able to answer a few questions today. And I'll just pause the recording now and we maybe answer some few questions. Okay. I hope Roy is still there.